So this is just function notation is when you instead of saying y equals, you say f of x equals. F for function, the function with respect to x. So how does the function change as x changes? The value, so that means, yeah. Same thing, like generally they'll use f of x. It's the most common one because of the word function. The next most common one might be g of x because it's the next letter in the alphabet after f. So quite often you'll see f of x, you'll see g of x, but it could be anything. Like if they're talking about the area of a shape, it might be a, capital A of x. Or perimeter, they might call it p, or profit and loss. V for velocity, and t could be time. So you could see v of t instead. So function notation is just a fancy way of writing y. So instead of writing y, they write fx equals. The reason why they started to invent this notation is you probably noticed you've seen graphs where there's more than one function graphed at once. So which one is y? So what they do is they can call one of them f of x, and then they can call the other one g of x. Oh no. Okay, so f of x and g of x is to show that they're two different functions. So a way of labeling functions just to show that they're different to each other. So every function has an equation, as you probably know. For example, just remembering some basic kind of functions. What kind of function is this one?
Quadratic.
Yeah, quadratic. So quite often you'll notice in this unit I try to go back to getting you to recognise what kind of functions they are based on either their graphs or their equations. Y equals 4x plus 1. Linear, yeah. An equation, you can just write linear if you want. What would be its domain and range?
X as being a real number.
Yeah.
Y as being a real number.
Yeah, these are easy. X-ER, Y-ER. They spread out infinitely wide and infinitely high and low. Quadratics are X-ER, but then Y is either greater than or less than the vertex, depending on the way it opens up. It might open up that way or that way. Yes, Krista?
Can I get a tissue, please?
Sure thing. What kind is that one? Cubic. Cubics that tend to be XER and YER, because this kind of goes like this. Ooh. So this particular one happens to go like that, but you can also get cubics that go like this. And either way, both of them are going to spread out infinitely wide, so XER, and infinitely high, because they're going up and down. So they're going up and down. So these ones tend to have the same kind of domain. Just throwing in a bit of review of domain and range as well. When using function notation, the equation of a curve changes slightly. Basically, instead of writing y equals, we write something else instead of y equals. So for example, the quadratic y equals x squared is written as f of x. So the y just became f with respect to x. So the y has been replaced with f of x. The letter f is used to distinguish the function from other functions, like just the fact that f of x is a different function to g of x. And both of those are a different function to d of x. Whereas if you call them all y, you don't know which one is which. Pretty obvious stuff. So examples showing d that could be any letter really that they use. G of x, they might use h of x for height, like quite often height with respect to time, or height with respect to distance. M of x, like mass or something like that. P of x, like could be perimeter, profit, loss. So yeah, you can use any kind of letters. You don't have to use x, like quite often they might use time instead, or weeks or whatever instead of x. Depends what's on the graph. Yeah, this is also obvious. So the x is written in the brackets as the function is written in terms of the letter x. If I write the equation of a quadratic as y equals m squared, then using function notation, I would have to write, instead of having x in the brackets, I would have to have m in the brackets. That's the only thing that's different. So if it was something like y equals m squared, you just have to make sure that you've got m there instead of x. So it could be t of m, for example, might be the time, or the height with respect to m, or the displacement, or the distance with respect to m. So just showing you that you have to just make sure you've got the right letters in the right spots. Example, write the following in function notation. So basically you can call the first letter anything you want. You can use f if you want, but you've just got to make sure that the letter in the brackets is the one that's appearing in the equation. So just making sure that you're a bit aware of that, because sometimes when you're asked to express a function in an exam, people sometimes just always go y equals, or they go f of x equals, but maybe it's not x, maybe it's p that should be in the bracket. So we can call this one O for Owen. O with respect to what letter? X, yeah. So 6 of x equals 9 minus 5x. And what we'll do, K for Chiesa. K with respect to...
Miss Valerian, how do you say Chiesa in IB2's name? No, in IB2 Chiesa? You know Chiesa?
I thought it was the same. I'm not sure though. I could have it wrong because I've never had her in my class.
See, don't snooze it, because then you'll just keep dismiss it.
Yeah. But then I'll probably get not so much book.
But she says Chiesa and Chiesa. So I'm wondering how does she say Chiesa?
Yeah, I thought it was the same. But I've never had her in my class, so I'm not sure. Doesn't have the experience. So K with respect to P in this case equals 2P squared 7. So see, I'm just making up the first letter. Lauren with respect to E this time. Square root of E.
So what type of function was that?
Oh yeah. might be one like that. Doesn't have a particular kind of name. You could maybe make it up, square root function. Yeah, it doesn't have a special name. Doesn't have a nickname. So y equals 6 over 5a. Make up something else if you want. Make up your own one. I just made up h. So we've got to have a in the brackets. 6 over 5a. Because weirdly enough, it does happen in exams. People just naturally start to write f of x, but maybe it wasn't f and maybe it wasn't x in the function. Yes, Isabella.
Letters before the brackets?
Yeah, I don't think so.
So can you put X at X?
Oh, it could be capital X and lowercase x, yeah. Like, because things like temperature and time, like capital T with respect to lowercase t. Because capital T is a different variable to lowercase t. Because capital T could be temperature, lowercase t could be time. Yeah, so you can have the same letter, but you couldn't have the exact same letter and the exact same case. Like it couldn't be capital T of capital T or lowercase a of lowercase a, because the variable with respect to itself kind of doesn't form a coordinate plane anymore. You have a coordinate plane is based on two different variables, x and y. Yeah, so anyone can use, sometimes the letter I could be, no, I've seen the letter I used, but sometimes it gets mistaken for a number 1. Evaluating functions. So quite often you'll be asked, you won't be asked to substitute in -3. The command in an exam will commonly be something like this. So you just need to understand, what does it mean if it asks you to find that? So,
Substitute -3 with X.
yeah, exactly. So they'll normally have given you a function, and the command will be to put in -3 where the x is, but the way they'll say it is like this. So it's more just being able to interpret function notation. So what kind of function is this, baby?
Linear.
Linear, yep. It's a linear. So again, just trying to practice what kind of function it is as well. What's its gradient? Good, -2, yep. And its line intercept? 7, yep. So it's kind of going to be going down like that. Just a little bit of side info. So when you're doing this stuff, you do your little golden step where you start stuff in. And you just work out the answer. Feel free to try that non-calc. And that will be, you just call it 13, yep. 7 minus -6. So it's going to be 13. I don't have much space to write the working out, so I'll just show my little subby step. F of 0, to be obvious. 7 minus 2, 0. What's that going to be? 7. 7 minus 0 is 7. 7 minus 2 is 9. that going to be a negative answer? Or positive?
Negative.
Negative. Looks like a
Negative 11.
Negative 11 to 7 minus 18, yep. And then we've got... So see how examiners find it really easy to mark your working out if you write it like that, like brackets to multiply, that kind of thing. So I try to make it as easy for the examiners to give me method marks, rather than use multiply signs and that kind of thing. The bed mass, yep. 2 times negative a half, what's that?
1.
Yeah, negative 1 or positive 1?
Positive 1. Negative.
Yeah, I think I know what you mean, you're both right. As in this part is negative, but overall minus negative is going to be plus 1. Yeah. Good. So you're both right, so did you get 8? Just practicing our non-calc number skills. More difficult example. This one will have an asymptote. It's what we just call a rational function. It's got an asymptote. Because who can we divide by 0 in math? No. Yeah, only that guy. So what value of x will make the denominator 0? 4.
So it can't be 4.
Yeah, exactly. So just a little note, there is an asymptote. Doesn't relate to the question that they're asking, but I just put these little notes on the side. Is it? I should have waited till then, shouldn't I? Darn it. Okay, so G of 2. So notice it's capital G. So if it's capital G, if ever, just make sure you would use capital G when you wrote anything about it. And then you do this is a G of 2, 2 of 2, 2 minus 4. What's that?
7 over negative 2.
Yes. 7 over negative 2 or negative 7 over 2, that kind of thing, or negative 3.5. All are correct. So we got 7 over negative 2, which overall is a negative, same thing. Yeah, what value of G of x does it not exist? X equals 4. So you want that's related to this. You could say as we cannot divide by 0. So do you know what I mean by asymptotes? Like little dot 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 graphs? Things on the graph? Yeah. Regions where the graph can't exist. Mathematically. Find x. Yep. So this is common. Seeing the difference between that kind of question and that kind of question. So this one's asking you to substitute. This one's asking you to do something else that starts with x, but it's not substitute. Something to do with algebra. Yeah, you're going to have to solve. Because they're telling you that this thing here equals that. So that's commonly mistaken for a substitution question, where people think that you're subbing in. So 2x plus 3 is equal to negative 3. So nice easy way to start, just set the equation equal to the number. So now it's solve. So how would you start to solve something like this? Yep, that's right. So you could multiply this one over. Or do, or however, yeah. And that's what you meant, yeah. So, feel free to just go ahead and solve it if you want, and then you've got the same answers. I guess looking like you've done really I'm going to put in a mistake. Okay, I put in a mistake somewhere just to try to make it more interesting for you. Yes, exactly. See, I added 3 instead of took it away. In time.
Yeah, I was
You're right, yeah, okay. 9. So you could leave your answer as 9 over 5. What would that be as a decimal out of interest? Yeah, 1.8. Yep, 1 4/5, and 4/5 is 0.8, so 1.8. Yay. So that's what happens a lot in SL exams. There'll be a stream of questions. Quite often in calculus units, there's a stream of questions where to start with, maybe they want you to do that, and then the next one they want you to do that, or vice versa. And it is very common that people tend to always think this thing means substituted in. So just be wary of those kind of things. Let's go on to composite functions. Composite functions, like when you're embedding a function inside a function. So the notation you probably had in CIE was that they would have the outside function and that this would be in there. How was it taught to you? In like what kind of wording? How would they describe it? Just what I just said? Would some people call the outside one the mother?
no.
Okay, I won't do that.
Miss Willie, that's something you say to primary.
But you know when you're trying to like just communicate which one's on the overall function, which one's the inner function.
Yeah.
So sometimes people, but the word sounds weird when you say it, like mother function. That just sounds weird. So I'll try to avoid saying that. So if there's a word that you want to come up with instead, that sounds better. So topic follows on from functions. Instead of substituting in a value of x, instead you replace x with another function. And then expand and simplify. Simplify. Very appropriate. So it's important, like f of g of x is different to g of f of x. Would it be told to you like that? Would you call that f of g of x?
Yes.
Okay, yeah, and g of f of x. That's the words you would use, teacher. I like this kind of stuff. Just loads of algebra. So the overall function, the mother, is f in this case. So do you like to do it like this? Just do it the way you know how to do it if you've been taught it before. Actually, so x plus 2, I've got to replace the x here with 3x minus 1. So instead it's 3x minus 1. Maybe I'll colour code it. And I'll do that one with blue. 3x minus 1 has replaced the x. And we've got plus 2. And then just work out the answer. Yes, Lauren.
What are the exercises in the textbook for this?
Are these from the textbook?
No, I'm just wondering.
Oh, what are they?
Yeah.
Yes, that's a good point. I should start to. I need to give you a replacement page of page 1 and 2.
Okay.
And what I might do is I'll fill it into where I think the unit's going to finish, and I'll just leave some blank space. So if we do end up adding extra lessons to it, I'm not sure if this is getting combined with quadratic functions, because at the moment on our scheme of work, this is listed as a unit, and then the other unit is going to be quadratic function, but they can be merged together. So what I might do is just give you what I think it is, and then leave some space, and we can always paste in some more stuff on the table. That's a good idea. Yeah, so there is in the textbook, there's a section on functions. It's got domain and range, composite inverse functions. I think it's early, it's like chapter 2 or something, or chapter 1. This unit will also include a little bit of reciprocal functions and loads and loads and loads of graphing. So after we've done domain and range, composite and inverse functions, we do reciprocal functions review, and we do loads and loads of graphing and solving on the calculator. Yeah, so then you can find like terms, what overall does this become? Yeah, and the next one. So g of f of x, so it's 3, put into red, and you can code it if you don't want. But instead we're replacing x with x plus 2. So my overall outer function is the red one, and I'm subbing in the blue one. do this on which right. Did you get the same answer as me? It can be the function of itself, so it is possible. You can have g of x. Totally possible. Might feel weird. So we're subbing the function itself into where x is. So 3x minus 1, and then minus 1 here. So that overall is 3x minus 1, but we'll replace the x with the function itself again. G of x. And we've probably got 9x minus 3 minus 1. Hopefully get that too. And just the same, f of x is possible. So replacing the x with the function itself. X plus 2, and this is 2 overall. In GCSE, the notation was probably always like this. In IB, you're going to start to see notation like this, plus you'll start to see it written like this as well. See this funny little miniature dot? I might call it G of kind of thing, like f of x. Yeah, exactly, yeah, it means the same thing. Yeah, and it's not like an O, it's not big enough to be an O. Yeah, it's kind of like it, and it's kind of floating in the middle somewhere.
How do you know when to use brackets and not when to use brackets?
With that one?
No, like when you were subbing it in.
Yeah, if I did that, it's not.
Yeah, you could do it, yeah.
Yeah, nothing's wrong with doing that at all. It's just the answer overall is the same. Yeah, so if that helps, just put it in. Like, no problem with doing that either.
But if you do that, then you just.
If there's a number in front, you have to put in brackets. If it's not
Yeah. And these answers overall become the same. It's just the same.
But if you have the brackets, could you just like not solve for them?
Oh yeah, then you would still have to collect like. Yeah, like as in x plus 2, and then plus 2 is still just x plus 4. So if you're in doubt, just put the bracket. Like if you were subtracting something, you would need the bracket. Like if this was being subtracted, then the bracket's totally necessary. Or else it would just be minus x plus 2 when it should be minus x minus 2.
Yeah.
Yeah, so maybe it's a good idea to put the brackets in when you're subbing the thing in. So no, oh, there's another one. Here we go. So here with some exponents. Let's do these ones in green and purple. So what's the mother function on the first one? F, yep. And then the baby function, whatever. I don't know, it's in there. So overall, it's x squared, but this entire x is being replaced with 5x. So I'm going to put 5x and then pop it in a bracket and square it. So see, my overall one's green, and I've subbed in purple. What's 5? Is that the answer 5x squared?
No.
No, good.
25x squared.
Good. Yeah, 25x squared. And G's over to this one.
That answer is
5. I in x squared, don't I? So there's 5, and then replacing the x with x squared, the other thing. Is that 125x squared?
No.
Okay, good. That's 5x squared. And again, that could have been written as f of g of x. It could have also been written as g of f of x. Calvina! Yeah, so we're really ripping through this. What was G again? G was which one? G was 5x, okay. So 5 of 5x.
wondering if it's like F bracket G, like so the G's on the inside.
Yeah.
Is it G of F? Or is it F?
F of G, yeah, still the first letter.
Oh, okay.
The order of the letters is still the same as it was in the old notation.
Oh,
Yeah.
okay.
Yeah, you're right. The first letter is the mother, the umbrella function, the alpha. I got 25x.
I want to hate you right now because if it.
But that's just so different to Friday.
I know.
Were you at school yesterday?
For half the day.
Yeah. And you were at school day 4.
And then did you have
You had a very nice week.
That's the 4 for that one. And let's keep going. I should have turned this into different videos. Oh.
Your videos are already on the.
Does anyone listen up? Huh?
Aren't your videos already up on the.
Oh yeah, I could just leave the old ones on there, couldn't I? So I'll probably go into a bit more detail. Unless people like to have their own voices in there. Yeah, so f of x equals square root of x, and g of x equals that thing. I want to color code it again, it's fun. Christmas colours. Okay, so f of g of x, so the mother this time is f. Oh, I don't want to index. You don't have to color code it. I'm doing notes. And then you're replacing the x with x plus 2. And can we simplify that one anymore?
No.
No, it's done. Lovely. And then the mother this time is x. X. Oh no, I'm doing it.
Square root.
Yeah, I should be subbing in first, shouldn't I? Yeah, x. Square root of x. Plus 2. Yeah, so 2 different answers. And g was G of x. Okay, oh yeah, got you. G of x. I should have stopped worrying about the colours. X plus 2 plus 2. Like Isabella just said, x plus 4. You've got that one already.
This one's going to be tricky.
Yeah, this one might need to use a bit of index laws to simplify it.
Wait, is it like the root of root x?
Yeah.
How do you simplify that?
Yeah, exactly. Square root of x and then square root of that answer. So let's use exponent laws. Square root of x is the same as x to the power of?
Negative 1 over half.
Close, yeah, a half, yeah. So a half of a half. Yes, that might make more sense. X to the half of a half, which equals?
Actually, was 1 over 4.
Yeah, that's why you can multiply the exponents.
4 x to the power.
If you had to square root it again for some answer, for some reason, what do you think the...
Just put it. It'll be x to the power of 1 over.
Yeah, 1/8, yep. Okay, and then another one, x to the power of 16, and so on. Yeah, so turning it into little exponent laws. I mean, exponents might be helpful there. Now we're on to inverse functions.
We have how do composite functions relate to
We can do the little how does it relate to the real world afterwards if you want, and then maybe we'll just bomb through inverse, and then I'll stop the video and then we can read through that. Inverse functions. I like this stuff too. So this is where your transposition skills can come back. So remember back to our logs unit in year 10, but really it could be in IB1 as well, because you did do logs in IB1 again. So in exercise 30, you asked to find the inverse function for a variety of exponential and logs. To do this, you just swap around x and y and then rearrange the formula to make y the subject, like what you did do for transposition. So you find the inverse functions. I've given you some inverse functions of where you're kind of going to be required to use logs or exponents to solve for it. So just because they're probably the harder ones. So what I like to do is I like to rewrite the function as y equals. That's my favourite thing to do. I think you'll probably do this. Do you write the function as y equals and then you swap x and y? Yeah. So I've just rewritten the original function and then now I'm going to swap x and y.
Times some x or 4x times x.
Yeah, it's time. Yeah, that's why x is not.
You don't have to switch the x into
No,
the y.
yes, thank you. Thank you for noticing that. I didn't even notice. X equals 4 times 5 to the y, not x. Yep, so we'll swap the x and the y over, and now we just use transposition. Yeah, it's nice, isn't it? Rearranging the formula to make y equals the subject. What would you deal with first, the 5 or the 4? 4, yeah, like the furthest away thing. How do you deal with it? Yeah, good, yeah. Divide the thing up. And then does this kind of thing look a bit familiar? Back to term 1? Logs, yeah. Ew, yes, indeed. So when you've got an unknown exponent, like because we want to make y the subject, you need to log both sides. So you could do whatever log you want. Log. Yep, I'm just going to do natural, not natural, is it? Common log. And then you could do natural log instead.
Is it log 5?
Yeah, 5 to the y, yeah.
5 to.
Yeah, that's right.
And then you can bring the y in front.
Yeah, some people go straight to bringing the y in front, which you're allowed to do if you want.
So that would be log x over 4 over log 5.
Yeah. Oh yeah, right, you're talking about the final answer equals y log 5. Yep, so log x over 4, like Grace said, divide by log 5. And the only common error some people might think they're finished now, but if it's if it was just transposition, then that's fine. But if it's an inverse functions question, they just want you to replace y with the symbol we use for the inverse function.
The FAX.
Yeah, that thing, f to the negative 1x. Yeah, so that's the final thing they want you to do. I'm going to do that in green. The function doesn't change at all, it's still log x over 4. So the log 5.
Yeah.
There you go, done.
Yes, in nature. Wait, are they in this one?
Huh? Huh?
These are the exchange students from Georgia.
I thought it was only one boy.
Is there well, are they arriving?
She's asking you.
Are they coming in May?
I haven't heard anything about them.
There's just an email.
Is this route square or like
How long is it just going to be?
Well, the thing is that our exams start May 30th and then they go to June 8th. So our exams aren't technically in May.
So that's fine.
They're coming beginning of May?
I don't know.
I think you're.
Because they want to.
That's
So neat.
I guess because it's summerish.
Yeah, your exams tend to be late May.
Yeah.
Mid to late May. Yeah. Are they?
Because I looked at the
Normally yours are a bit over before middle school, but I think last year they were trying to make them all hit at the same time. But normally, traditionally, yours are before middle school. I don't know why. So that's the final way to write your answer, f minus 1x. Let's go back and do another one. Oh, we've got a log instead. So, oops. So start off, just rewrite the question as y equals, if it's not already, in the form of y equals. It's log base 7. And then we swap it over. Then we're back to... So just rewrite the... See in green, I've just written the original function. And now we're about to swap x and y over. Then we've got to decide what do we deal with first. Do we deal with the log, the 7, the 4?
4. Divide by 4.
Good, yeah, divide by 4, yeah. So we still...
Thank God. No one works every day now.
Different ways you can do this. I would suggest now turn it into exponential form, like exponential form. What's the base going to be in that case? 7, yeah. And what's the exponent going to be? Yeah. So the exponent is x over 4 equals y. Oh, that was really messy. Look at that.
So then we have to change it into x to the negative 1?
Yeah, and we're done. Yep. X over 4, yep. So turning it into exponential form was nice. So then we just go f minus 1x equals 7 to the power of x over 4. So that was nice and quick. It looked like it was going to be horrible. Is that the last page or is there more? That's the last page. Okay, yeah, that will do for now. We will be doing some more. Like that was an example of a harder inverse function. So the next lesson that I'll print off and give to you will be inverse functions continued, where we look at graphs of inverse functions as well, how they relate to each other. So I can just stop this one. Anyone writing that down? Oh, just anyone copying that down because I'm just about to stop it and change page. Yep. Okay, so you're done. I'll just quickly stop the video and we can start